Okay, Bismillahirrahmanirrahim. Okay, so just today we will cover a very quick introduction to Python. How many of you are familiar with Python? Some. Okay. Okay, that's not a problem because we will not, I'll not assume that they know anything. Actually, textbook also is not assuming that they know anything. But the textbook is assuming that you don't know anything about programming, but of course that's not our case. So we'll go through very quickly. Okay, and this introduction is not generally not very general about Python, but it will do it with the goal in mind, which is learning data science. Okay, so we'll see that some of the functions here we will really use in our course anyway. Okay? So we'll start with the programming language in general and why we chose Python. Python is of course popular for both data science and also general software development. I told you that I gave this course before in R, and I decided to switch to Python because of this, because it is really now very powerful for data science, and also it is general purpose so that you can learn from both sides. Of course, mastering the language fundamentals is critical, and it won't be just by reading or listening, so you have to practice. And that's why we have these notebook exercises to do together, and also you can do with yourself. And I will post, inshallah, even more than the ones that we will do together. So let's now start the first demo. And almost the entire lecture will be going through some code snippets together. So in the beginning, you need to install the data science package. Did you install Jupyter, Anaconda and Jupyter? Okay. Did you try the notebook? I posted it already with the slides. You tried it? Okay. So everything is going well. So you need to install the data science package. Okay. And this is with the NumPy are the two major packages that we will use in the course. Okay. So please install it first before you go through this notebook and the next ones. So see that we need to import these packages first. Then we'll go through quickly very traditional expressions. Sorry?
When I ran it was showed an error.
Yes, because you didn't install probably data science, so you have to install data science first.
How?
Can you search it, please? Okay. It is very easy, just one line. There is a command line application with Anaconda. You can just write this command and it will install it. So expressions, you know that we can use expressions, of course, in any programming language, and Python is not different. Addition, multiplication, division, and the division here is a bit not as usual. If the two arguments are integer, then the outcome of the division. Okay, so in Python it's not. Okay, so division in Python is always giving us a floating point number. Okay, so that's a bit different. Okay, whether the arguments are integer or not, the division is always giving us floating point numbers. Of course, you are also familiar with the order of the operations, right? Of the expressions. So what are the orders of the operation, the arithmetic operations? Division and multiplication together. Sorry, division and division and multiplication, then addition and subtraction. How about power? Is before them even, and parentheses is even before. Okay, so that's usually the order. Okay, so if you do that, then you will get 20 from here and similar here. Please stop me at any time if you have any questions. Most of the stuff that we will do today is very familiar to you. If you have any questions, just stop me. How about this one? This is maybe a bit different from other languages. So in Python, we do the power operations using the double asymptote. Okay, so in this case, this will be 2 to the power 3, which is 8. Okay, so this is very quick intro to expressions. Now we'll move to names. What the textbook calls names is actually the variables that we know in programming languages. Okay, but the reason why I think the textbook is not calling them variables, because we will use the term variables in a bit different context later in the course. Okay, but names here are the variables that we are familiar with in any programming languages. So the assignment statement, of course, you know that 2 sides, left and right, we get the value of the right-hand side expression and assign the value to the left-hand side, the variable or the name to the left-hand side. Statements like the assignment statement doesn't have a value by itself. Okay, and this is different from Java. I think in Java, the value of the assignment statement is the value of the right-hand side and the left-hand side eventually. Okay, but here the statement itself doesn't have a value. Okay, the value is only for the name or the variable. Okay, so this is a statement. This is an assignment statement. Okay, in Java the assignment statement has a value by itself, and if you print the assignment statement, it will give you the value of the right hand side, which is assigned to the left hand side. Here the assignment statement doesn't have a value. It's just a command. Okay, so it doesn't return a value.
What does it return?
Nothing. It doesn't return anything. It's just a command. So it's just
how
an
can I give it a value?
Huh?
How can I give it a value? Assign a value for it?
It's the assignment statement itself will assign the value of the right hand side expression to the left hand side value. As usual, but it doesn't return a value. The assignment statement itself. Okay? Yes.
So if we like this out the hours per week, we will not get the 24.
Oh no. This is okay. I didn't mean that. Now the value of hours per week is 24 times 7, of course, whatever the value is. Okay? But what I'm saying is that the expression as a whole, the statement as a whole, is not a value. Okay? It's not returning the value. But of course, the assignment statement is done, of course, which is assigning the value of the right hand side to the left hand side. I think we'll see example like that in the demo. And of course, the name or the variable is bound to value. Always, any variable has a value. It's not an equation. Let's go through the demo here. So, a equals 6, so a will be 6. B equals 4. B is 4. Notice here something which is different from Java. What is it? We didn't explicitly mention the data type. We didn't say A is int or B is int. Okay, we don't specify the data types in Python. Okay, but that doesn't mean that the variable doesn't have a data type. It does have based on the value. Okay, based on the value. Okay, so here the value is integer, so the data type of A and B here are integers. Okay, and I can change the type. Okay, at any time. For example, if I put here, let's just change this for now, A equal ABC. Okay, that's a string. Okay, and I printed A, then I will get ABC, although A was 6 before. Okay, in other languages that might be an error, right? Because we changed it, but here in Python, it's dynamically changing based on the value that I assign, the last value that I assign to the variable. Now the data type for A is string. Yes.
So now if we run the total, we're gonna get an error, right?
Yes. Let's do that. Okay. Let's do that. You get an error.
Can you give us an example of the assignment, the statement assignment that you explained before?
Okay. So just doing this didn't return a value. Okay. But the variable itself has a value. So that's an example. Okay? Did you get that now? Okay. So we got here an error because B is of A was in a different type. Now we ran the cell of A again. Now it will work. So total is 10. Okay? Length, width. Sorry?
Can we use casting here?
We'll talk about that. Yes, we will use something similar to it. Okay? Yes. Okay, here of course this is another assignment, another variable, and so on. So nothing new here with just usual expressions. Okay. Why names here? So we'll not go through this. This is just saying that you should, as usual, we should always try to give names that are meaningful. Okay, not just A and B and C. Okay. Call expressions or calling functions. Okay, so as you know, the name of the function and the arguments. Okay, as usual. So this is calling f on 27. Sometimes the function can have more than one argument. Okay, so this is a function that has two arguments. Some of the functions in Python takes a variable number of arguments. Okay, so as we will see in the exercise, we can try it. You can give more than two numbers to max. Okay, and still will give you the maximum. It's not always one, it's not always two. So it can take much more arguments than these. Try it. Okay, try it.
We don't have to state before that this, for example, max it takes two.
It is defined like that, of course. Now this is a built-in function that's defined with a variable number of arguments. Okay. We will not talk about all the details today. This is just an introduction. As we move forward, whatever we need, we will discuss. Okay, and this is not, because this is not a programming course, right? We are not studying Python, but we are studying Python for data science. So that's why we are going through the things that we will really need. Okay. Let's go through the examples here. So the absolute function, of course, takes the absolute minus 5, length minus width. So that it can, of course, take an expression instead of just a variable. This is an example of a function that takes a variable number of arguments. So the minimum of these is minus 3. We can add, if we like, we can add more, and it will change. Okay.
So what is the return type of this function? Is it integer or void?
Okay, you can look it up, but let's try something like this. So it takes also floating point number. If I put this, okay, so it returns also float. So generally it depends on. It seems to me that it depends on the type of the arguments. If all of them are integers, then it will return integer. If some of them are not, then it will return float. Round, as you expect, rounding a number. Okay. So what do you expect of the value of this? 123.5.
123.46.
Okay, so if I give a number to the round function, it will round it to the nearest integer. Okay, to the nearest integer. Okay, so this now will be 123. Now, if I put another argument, then it will approximate, or it will round to that number of decimal points. Okay. So now, what should be the output? 123.5. Yes. If I made it 2, then it will be 4, 6, okay, and so on. Okay. Any questions so far? Sorry, it's the nearest, whatever. Minus 1. What do you mean? The decimal? No, I don't think it will work if we put minus 1 here, right? I don't think it will work. Oh, it worked actually. So what's the meaning of this then? The last one from the whole number. Okay. No, why I would think about that. But yes, we can try it. So the nice thing is that you can try all of these things. You don't have to memorize these things. You can try them and see what will happen. Okay, interactively. Don't have even to run any compiler or interpreter or any environment. Just in your web browser, you can do everything. Now we'll talk about another type in our course, which is tables. So tables is a special type that is defined within the data science package, okay? And many of the work that we will do will be on tables. So this is very important. We'll go through an introduction today, but I think next time we will focus more on tables. So as you expect, the table structure is a sequence of columns, okay? But each column is labeled. So each column has a name. Each column has a name. We'll see examples, of course. And each row represents one individual. You see now the terminology of data science that we discussed earlier, right? We said that an observational study has three components: individuals and treatment and outcome. Okay? So each row in the table will always represent one individual. Okay, so all the individuals are represented in the table, in the rows. Data within a column represents one attribute of the individual. Okay, we'll see an example of that, but it's like a feature of the individual. Okay, so we'll have, if we have students, maybe one column will be the name, another will be the student ID or QU ID, and so on. And here's an example. So we have three columns here. Each column has a label. Okay, so it's not just an index, it's a label. So we have name, code, area in meter square here. And the column represent one attribute of each individual. So the attribute here is the code of, I think, the state here. And as we will see later, all the values of the column have to be of the same type. Okay? And this is the O. So let's go through an example here. So we'll read a table, okay, about ice cream cones. So we will have this data set has 6 rows, okay, and 3 columns. Okay.
Now, did you draw it, Victor, or what did you do? Is it reading function?
Just read table. So that the function, the method from the table package, table type, sorry, is called read table. That's it. So read table, we'll read it from the file. Of course, it is in a local file, and just by this command, it will read the table. Okay.
So
Now.
It takes the data from the file and draw it as a table.
Yeah, cones, yes, because we said cones, that will be it will display the value of that variable, which is the table here. Then we show a number showing the top n rows from that table. So show 3, which show us the top 3, the first 3 rows in the table. If we just exclude the number, then it will show everything. Okay. As you will see here, the trend in Python is always that the code is very tiny, very neat, okay, with very small, not even number of commands, maybe number of characters writing the command. You will do really nice actions. Yes. No. No difference in the notebook here. Okay, show, but show is always giving you the table in a specific format. Yes, and also whenever you say the number of the name of a variable, then as by itself, then in notebook it will be displayed. So in this case, it is the same. If I want to work on a specific column, then I use the method select. Okay, so cones.select flavor, it will give me only the column flavor. Okay, if I want to select more than the flavor column, then I mention a list of columns. I can put here any number of columns. Okay, just select flavor and color here will give me flavor and color columns. Okay, so you see very simple and logical. Okay. Methods. Similarly, I can drop columns if I want just to delete or to remove one column or more from the table, I can just say drop and the name of the column. Then I get only the remaining. Okay. Notice something here. When we select or drop, it doesn't change actually the original table. Okay, and this will be clear from this. So if we write cones here, again we get the original table. Okay, so select or drop actually create a new table with the new columns or whatever the method that we are doing. Okay, it doesn't change the original table. Okay, if we want to keep the original table, of course we have to assign it to another variable and then use it.
Which ones?
Hmm?
Drop and select.
Sorry?
Drop and select, you said? Which ones that we need to do?
What we had so far, yeah, most of the methods in table doesn't change the table itself. It creates another table. Okay, so whenever we select rows, we select columns, we drop columns, all of these will create a new table. So the original table doesn't change. As you see here, after we drop the color, okay, so colors no cones no color is the one that doesn't have the color. Okay, you see that?
Even
But cones has. Okay.
even if we use the drop, it doesn't change the original table, right?
Even if we used
And drop method.
drop. So drop will create a new table, but without this column. Yes. Okay. Any questions so far? So selects specific columns. Drop will drop specific columns, and you can specify one column, two columns, any number of columns. Okay, but you have to specify the name as they are. Exactly. Okay, the names of the columns have to be exact. Otherwise, the command will not find the column that you are talking about. So it's case sensitive, of course. If I want to select rows, so selecting columns, which method we should use? Select. For selecting rows, we use where. Okay, we use where. We'll talk about where in more detail next time, but for now, you can think of it as a way to select rows with some conditions. Today, we will only focus on the exact match condition. So we give the name of the column and the value that we want to select. Okay, and it has to be exact. Okay. So with this command, we will select only the rows where flavor is chocolate. So you'll see that we have 3 cones in this data set with chocolate flavor. Okay? Clear? Sorry. We can also sort based on a specific column. Okay? So sort, then you give the name of the column, will sort the entire data set, okay, whatever the data set that we have here, based on the values of that column. So if we sort based on the price, you will see that by default the smallest, the cheapest will be at the top, and the most expensive will be at the bottom. Okay. If I want to do the reverse order, okay, this is ascending order. If I want to do it descendingly, then I have to specify another argument, which is descending, and give it a value 2, so that the order now is from highest to lowest. I can also sort not only on numeric values, but on string values. Okay, remember flavor are strings. I can sort the array, the table, based on the flavor. Okay, so you see here S, and it is descending. Okay, so strawberry comes before chocolate, comes before bubblegum. Any questions so far? Yes. Counting? The length, I think.
No, I want to know like how many chocolate flavor are you having.
Of course there is, but we will not go through it now. Yes.
How is the sorting based on the flavor? They are
How so? Lexicography based on the strings,
what in that? Based on what?
on the characters,
The length, and
not the length, of course. the alphabetical order. Yes. Okay. This is an example of reading another data set. The data set of that indicates the salaries of NBA players. Are you familiar with NBA? Basketball tournament in the US. Okay. So here we are reading a table of salaries of some players. So this is the data set. You see the player, the position of the player, the team of the player, and the salary. Okay, can you guess the unit of the salary here? Millions, yes. So this player is getting 18.7 million per year. Okay, of course this is comparable to what CS students get. Okay, sorry?
Why did we use related function?
Because the original, I think the original data set doesn't have the name salary here, so we want to relabel it as salary. So we indicate the number of column, which is 3. The number of columns starts from 0. Okay, so 0, 1, 2, 3, and we want to change the name of the
So
label.
it's like mapping between two tables, right?
No, it's not mapping. It's just renaming this column. Okay, there's no two tables here. It's just one table, but I just want to rename the fourth
Can
column.
we remove the label?
You can try it. Yes, just for the time. You can try it and see what will happen.
Doctor, another thing.
Yes.
Can we see the CSV slide?
Now it's just comma separated file.
Oh.
Yes, you can also see it. Yes, I posted you saw the notebook for the first lecture, right?
Yeah.
Okay. Yeah, I will also post this with the data sets, so you can look at them. But CSV is the comma separated value format that you can see also in Excel. You can open it in Excel and see. So what are we doing here? Sorry. Who's? Yes.
The number is 3. Is this for the column number?
Yes.
So it just start with 0.
Yes. But forget about this. This is it's just a minor thing now. Even if you didn't get it, don't worry. Okay. And whenever you want to explore more, you will have the code. You can play with it. Okay. Where? What are we doing here? What do you expect? Yes, we select some rows. What is the condition?
Golden from the column team.
Mm-hmm. Can you explain that in natural language? What will we get here?
Show the team in the Golden State Warriors.
Yes, so show the player list of that team. Okay, so all players of that team will be displayed. So you see all the players here of that team, Warriors team, will be listed. How about this one?
Just selecting the row here with this.
Huh?
The data of
Yeah, assuming that the names are unique, well, how many rows we will get here?
one row.
Just one, right? Just one, because there's just one player called with this name. How about the last one?
So it will sort the salary of the team that
The players that have the position.
Yes, the players that have this position.
Their salary will be sorted.
Yes, so we'll sort the players of that position, okay, based on their salaries. Okay, based on their salaries. Okay, so all the players in PG, I think pivot ground or something, will be shown but sorted with their salaries in descending order. Okay, any question about this? Very easy, right? And this is a summary of the operations that we saw. Select columns, drop columns, sorting based on a specific column, and where when we have the label and the condition. What we studied so far is just the exact match. But next lecture we'll see how we can change this. How to display just the row corresponding to the player who had, okay, so I will leave that for you as an exercise. Okay, and this also. This is just playing with the columns of the table. Now we'll move to the numbers. And talk about numbers in Python. So with the operations, of course, you are familiar with all of these: addition, subtraction, multiplication, division. As we said, the division is always floating point division. Okay, so the type of the outcome is always floating point, even if the arguments are integers, and even if the division is whole integer. The remainder, as usual, the percentage. The exponentiation, the power is double asterisk. So let's see some examples. So this is just a number. This is integer. As you see, this is float. How about this one? Float also, right? So it will be 5.0, which is a floating point number. How about this? Yeah, I understand that. I'm talking about the type. What will be the type? No, this will be just an integer because the number was integer. If the number was not, so like this, then it will be floating point. So it depends on the number that we are.
So the set of the division show, even if they are integers, show floats?
Yes, yes. This is what we have here. Okay, okay. So this is a big number, 1, 2, 3, 4, 5, 6, 7, to the power of 890. Okay, so question or? Yeah, it will be integer, but this is a very big number, right? So this number is really not a small number, and we are taking the power of this to this, okay, which is also not a small number. So we expect a very big number, right? Okay, how large it is? You expect it to be very, very large number? Okay. So prepare for the surprise.
Wow. I didn't expect it.
So that's the outcome of this. Okay, this is how powerful Python is in terms of numbers. Okay, so it can actually get this number. Of course, we will not need that number, I don't think. Okay, but it shows you how powerful it is. With that, of course, there is also a limit. So going to the limit, you will get infinity. Okay, but you see the limit, how the limit is actually a limit. It's not a limit at all. It's a really big number. Okay, back to division. So what do you expect from this as a value? 3.3. 3.3 only? 1.3? It should be 3 to infinity, right? It should be, but of course we are limited in computers, so the number has to have limited number of decimal points. And you will see here there is a 5 here, which is long, of course. Okay, so you would expect that in Python that sometimes the lowest decimal points will have some errors due to approximations and limited representation. Now look at this number. Also, the number of decimal points that are saved are limited. Okay, so you wouldn't expect to save all of these. So what is actually saved is up to
247.
where is that? 925. Yeah, here, up to here, and it was rounded, kind of rounded. Okay. Now, if you subtract this from that, which is here, what would you expect to get? 0, because both are represented in the same way in computers, in Python at least. Okay, here, what do you expect? Look at this and tell me what do you expect as the output.
2 times square root of 13. 2 times square root of 13.
No, it's not 2 times. It's double asterisk is power. So it's the square root of 13.
It's the power to 13.
Power to 2. So we should get 13, right? Okay. Here is what we get. 12.999999, which is kind of 13, but because of course each operation is done in order, and each operation has its own limitations in representation, so that is propagated, of course. Okay, so instead of getting 13 back, we didn't get 13. Usually these problems will not be big problems to us in data science, but you need to be aware of that. Here is what you call typecasting. Okay, so int of an expression. So 10 divided by 5 without int should produce 2.0. Okay, but with int we will get 2. Okay, so that's kind of typecasting. How about this?
It's a float, but it should be round.
Should be? Huh? What's the value? 2. Right? So it should be 2.5. That's 10 over 4, right? But the integer value of it is 2. Float of 3, we get 3 as a floating point number. 6 over 4, 1.6, 1.5. Okay. 6 over 4,000, that's a small number. Okay. Now, if I increase the denominator here, I would expect that this 15 will shift to the right? Okay. But what will happen is that we will have the scientific notation. You are familiar with this scientific notation, right? So what's the meaning of this? 1.5 times 10 to the power minus 56. Okay. Now, if we multiply this number, this denominator, with this, we would expect to get 6 back, okay, which happens here. This time it worked, previous time didn't. You can also use this scientific notation as a number in your expressions. You can assign a value to a variable. How about this one? 2x, what will be the value? 10? Okay, is that the way we use in programming? Okay, that's an error, of course. Okay, we don't do that. If we want to do that, what should we do? 2 times the star asterisk x, as usual. So that's the solution. Yes.
When we multiply the 4 with the number zeros.
When we multiply
When we
it?
multiply this 1.5 times 10 to the power minus 56 with the long
Yes.
Why did we get
6?
this as a
Because it was as float, because because that number was float. This number is float, of course. So float times.
When the number is integer, we don't always get it.
But these are not integer. This is a float.
The answer, the answer.
If both are integers, then you will get integer. But if one of them is float, you have to get a float. That's the multiplication operation. Okay. Round 3.7. So that's another function. 4. Okay. And as we said, round with one argument only, it will give you an integer value. Okay. If I want with decimal points, then I add another argument, like this one. Then we'll get 2.0 here. Okay. It should be 2.00, which is the same like 2.0. This one, I think, related to your question, and you will get 30.0 here. Okay. Any questions? Okay. So back to slides. Integers and float. I think you know the difference. Integer has never a decimal point. Float might be printed using scientific notation. There are three limitations to the float values. They have limited size, but the limit is large, as you saw the very big number. They have, on the other side, on the other extreme, they have limited precision of 15 to 16 decimal places, so you cannot represent more than that. And after arithmetic, as you saw with multiple operations, you might get some few places, decimal places that would be wrong at the end. Look at these expressions, and here we should get the largest number out of these, but let's do them in pairs. So how about D and D? Can you look at this and tell me which one is bigger?
Which one is bigger?
Yes. D?
E?
E?
Yeah, D bigger.
D or E?
I think D bigger.
A.
Yes, bigger. D is constant.
B? Okay, D or E?
D.
E.
Type, why is it E? Yeah, Aisha. You said E, right? Okay, why is it E?
3 over 10 will be yes, like 0 point something, and if we divide 10 over this number,
Yes, so the order here is different, of course, right? So what is the order here? Because in the parentheses, this will be done first, right? How about this one?
it's
10.
They are at the same level, so if we have two operations at the same level, what should be done first? From left to right. Okay, so 10 over 3 first, then divide by 10. So this will be 3.3 divided by 10, which is 0.33. Okay? And here, it's 3 over 10, which is 0.3, then 10 over 0.3, which is, of course, bigger than the previous one. Okay? You can think of the others also similarly. So these are the numbers. Eventually, the number C is the largest here. Okay, strings. So of course, strings are snippet of text of any length. In Python, you can, by default, okay, or usually you use single quotes to indicate strings. Okay, it can of course be of any number of letters, like word. And also we can use double quotes. But usually we use double quotes just to avoid the case when we have within the string, we have single quote. Like this. There can be two sentences. Here is, so this single quote, just to keep it within a string without any problem, then we can use the double quotes. Okay, but both are the same. Both are equivalent. Single quotes or double quotes. But in this case, you have to use double quotes. Okay, you cannot use single quotes.
Even if it's one character, we use double quote, it's okay.
Yes, even if it's one character, both are the equivalent. Okay, both are equivalent. But if you have a single quote within, then you cannot use the single quote, because if you do that, then the interpreter will see the first and the second single quotes as the string. Okay?
If it is one character, so it's considered as character or as a string?
We didn't talk about characters yet, so this is just the string is with single quotes and double quotes. Okay. Strings consisting of numbers can be converted to numbers. So here's an example. So int of 12, okay, because 12 can be converted to a number, so it will be converted to a number, so we'll get 12 out of this. Float, same. Okay. Any value can be converted to a string. It doesn't have to be a number, of course. So 5 can be converted to a string, and anything can be also converted to a string. So let's go through some examples here of strings. So we have flavor, that's string flavor. If we type flavor without any quotes, what will happen? That's an error, because there is no variable called flavor, it's just a string.
Printed with the single quote.
Sorry?
Why it is printed with the single quote?
Why? Because it's a string.
Why it's printed with the single quote? It should be printed without just flavor.
No, it just shows to you that this is a string.
In the
It is printed that way, with the single quotes. This is the way it's printed. The string, when the string is printed, it's printed with, because it's a value. Okay, so the value is.
Because in Java, it was,
Yeah.
Even if it's between the single.
But that's not printing to screen any. That's not using the print statement. This is printing that value, so it prints it with the quotes. Here, it's the same string, and you will see that it's also using a single quote because these are equivalent. Okay. Don't always use single quotes. That's another statement. Now look at this. We used here, instead of double quotes, we use single quotes. What will happen? Error. Okay, because it thought that Don is the string and the rest is something that is not well formatted, so it's a problem. Concatenation is done as expected with a plus. Okay, so you can concatenate two strings. Spaces are not added here, and if you want to add a space, you will add it explicitly. How about this? This is nice. Can you multiply a string with a number? Okay, the way it works here is that it repeats the string. Okay, so what do you expect from here? Okay, the one that you see in social media. Okay, so ha is repeated 100 times. Okay, so multiplying a string with an integer gives you a repeated string with that number of repetition. If we do it with a float number, what do you expect? Then error. Okay, an error. Of course, I cannot have half of the string. It doesn't understand that. Adding a number to a string in Python doesn't have any meaning. Okay. These are the ones that we saw in the slides. Integer 3, it will be converted to an integer now. So you see now when they are not within the quotes, now this is a number. Okay, so 3 here is a number. It's not a string. Here, this is an error because so this is not a typecasting here. It's converting what's expected as a number in a string to a number. Okay, so it expects the number here to be integer. So that's why there is an error here. But if I made it float, then it will work. Now I get 3.0. I can also get string out of a number. Yes?
But it's actually a string.
Yes, it is a string, but int here means converted into an integer. But it's not an integer. That's why you got an error here. String of 3, what do you expect? String of 3. Okay, so single quotes about surrounding 3. And string 4.5, also string with 4.5. Okay. Quickly we'll go through so I will leave this one to you as an exercise. Types. So far we saw 5 types. We saw integer, we saw float, strings, built-in functions like absolute and round, and also we saw a table, right? So we saw 5 types. The function type can tell you the type of a value or a variable or even an expression. Okay. And the expression type, of course, is based on its value. So let's quickly go through these few things before we are done. So type of 10, integer, a equal 10. There is no type because we said that the assignment statement doesn't have a value. Okay, so there's no type here. Type of a is integer. Okay, type 4.5, float, ABC, string, NBA, table. You remember the NBA players? Okay, it's a table. Type of 2, a boolean. Okay, so there is type boolean here. And type of absolute is built-in function. Okay, any questions? So that was really easy, right? Okay. So I will post this inshallah online, and please go through them before next lecture. So this lecture is almost, I think, the fastest one maybe in the course. We went through chapters 3, 4, and 5. Of course, these are just very quick introduction to Python. So please go through them, and yes, it's 3, 4, and 5. Yes. Almost. There is a part of 5 that we will cover next time, inshallah. Okay. So go through them, and inshallah, the first homework will be posted this week, sometime this week, inshallah. Okay. Thank you.